Hello, everybody. I'm Kevin Enland. I'm an instructional designer with the Alfresco University. I'm here to introduce Jose Portillo. Jose works in Premier Support and is an RCS for Pearson. Jose is originally from Mexico. He lived in Canada as well, and now he lives in a place called Normal Chicago, where he describes it as anything but normal. So Jose's, one of his hobbies is he's an avid MMA fan. So if you have any interest in mixed martial arts, you might want to get with him, and he'll probably talk your ear off. So let's get on with it. And Jose, would you come on up, and he can go ahead and start his presentation. He's going to explain, his presentation is going to be on Solr sharding.
Thank you very much. All right. Check. Good. Thank you, everyone. My name is Jose Portillo. I'm actually going to be talking about Solr sharding, best practices. And before I dive into the actual topic, I want to talk about myself. So I've been with Alfresco for about 5 years. I'm currently a Premier Support engineer, and I've been with Alfresco for so long that I started level 1 support, went all the way up to expert support, and one of the roles I used to do also was a technical account manager. I did have some exposure to some consulting experience at Alfresco, so that's something that I did as well. So I have a lot of information on this deck slide. So if I don't make it to everything, I apologize in advance. So I may need to cut my demo short. So let's dig in. So what is index sharding? It means to split a single index into multiple parts, which we call shards. It was introduced in Alfresco 5.1. A shard contains a unique slice of the index, which is basically a collection of documents of your entire index collection. And documents get stored in a shard depending on the sharding strategy. So what are some of the reasons you want to do sharding? One of them is to improve search, because Solr is going to divide your searches into sub-searches and return your results faster. Another reason is to distribute an index, and that's one of the main ones that I've seen with customers, especially large enterprise. So one of the main advantages of doing this Solr sharding to distribute the index is that you can put your large index and break it down into different servers. That way you have smaller size indices. It will eventually help you to do a faster full index. For anybody who has done a full index from scratch, you know it can take a very long time. So when you split that index into smaller pieces, it takes a lot faster to do. It also allows you to scale horizontally instead of scaling vertically, which is the last thing you want to do. So let's dive in straight into a demo. So one of the setups I'm going to have for all of my demos is I recorded everything, and I have 4 Solr servers, which are going to be used for hosting Solr shards. I'm also going to have a share server, which basically is going to have my user interface, which is share, and an Alfresco repository. All of the 4 servers are going to be connected to the same database. In my case, it's going to be an Aurora database and the same content store, which is an S3 bucket. And the same thing goes with the share server, because it has a dedicated repository, so it's going to connect to the same database and same content store. So let's take a look at the first demo. We're going to compare the single index versus a sharded index. All right, so we're going to start by looking at the repository that I have in place. So I want to see how many nodes I have in this repository. In my case, I set it up to have 29,000, just for demo purposes. So the single index, which I call full index in this case. So I'm going to be using Fresco Search Services to create my default cores, which is the Alfresco and Archive cores. Let me see if this works. No, I don't think it's letting me. I'll try to explain all the steps so you guys can see it. All right, so I go ahead and create all of my single index. So I have my 2 cores, Alfresco and Archive. So the next step is basically to show you how in this server I have 2 JVMs, one to host Solr and the other one to host my repository, which is the tracking repository. And I normally encourage customers to do this because this way you can tune your JVM separately depending on your application. All right, so I have my setup already, and I have started my Solr server. And again, in this case, I'm only using one Solr server. So I should have only one instance and 2 cores, my Alfresco and my Archive. Very straightforward. So the next thing I want to show is how I can look at the size of the indices in terms of cores. So I look at the Alfresco core, which in this case about 31 megs, and the Archive core, which is 684K. So it's a very small repository, but it functions as a demo. I also show the size of the content store, which if you have used search services, you know that that's where we store transformation documents and other files. So now I go into the Solr summary page. And over here, what I'm interested in is that I'm checking the summary for my Alfresco core, and I can see that the number of nodes that I have in the index are about 29,000. So that's what I would expect from my single index configuration. So now let's take a look how we would do it with a sharded index. So I'm going to be using the same repository, and I'm going to shut down my single index instance, and I'm going to be starting up 4 Solr servers. And again, I'm starting them differently. I'm not creating any cores out of the box. Something happened here. Yep. All right, so we're back. So now I go into each Solr server, and I just want to validate that I don't have any cores created. So I haven't created my shards yet. So it's an empty Solr server, so I have 4 of them. The next step is to create the actual shards. So for this case, I'm going to be using the curl command to create cores. I'm going to specify the number of shards, in this case 4, and the node instance, because I'm in server 1, node instance 1, and I'm also specifying the shard ID. So as I increase the number of servers, I increase also my shard ID and my node instance. So it's very straightforward. I get a confirmation that the core got created, and I do this for all 4 servers. One of the things you want to notice is that I did use the ACL method for sharding, and I'm going to explain all the different methods that we have available. So we're going to go into all of the servers again and validate that I have all of my shards created. So I go back to server 1, I see my first core, server 2, server 3, and server 4. So each one has a unique shard. Now, if I want to look at the sizes of the Solr indices in each server, you can see that they are like 15 megs, 1.1 megs, and the last one is about 17 megs, because each set of documents went to different shards. So that was the first demo. I'm going to go into more detail as the presentation goes along. All right. So what are the types of sharding that we have available? In search services and Alfresco in Solr 4, we have two types, the manual and dynamic. Manual discovery basically means that you have to set up a map of all of your Solr instances. So basically, you gotta tell Alfresco where to find your shards. In a dynamic one, you basically set up a configuration, and then Alfresco takes care of finding the available shards automatically. And it's the preferred method to use in most of your deployments. So a manual sharding, basically, you set up the mapping, and the repository knows about the shards, the locations, but it doesn't know about the status. So if your shard goes down, or if it's lagging, the repository doesn't know. It just tries to query it, and that's about it. With dynamic sharding, though, it is, first of all, easier to set up. You also have the ability of determine which shards are available to be queried. For instance, in this diagram, they're showing when a shard is lagging or when it's really behind. So that's one of the benefits of using dynamic sharding, because you get the status of your shards. So let's take a look in a brief demo. All right, so we're gonna start by doing the manual configuration of sharding. So the first thing I'm gonna do is go over again and start up my servers and create 4 shards for the 4 servers that I have. So that's very straightforward. I'm gonna fast forward to this since it's just checking that I don't have any cores to begin with. And then after that, I'm gonna go ahead and create my shards, which is very similar to the previous demo that I did. So I'm specifying the number of shards, the number of instances, and the shard ID. So I increase the ID as I move from server to server. So once I do it to all 4 servers, I basically gonna go back to the Solr page and validate that my cores were created. So those will be my 4 shards in my 4 servers. So we have server 3 with shard 2 and server 4 with shard 3. Very straightforward. Now I go on the repository side. Now the repository side is the one that's gonna be performing the searches. So this is the one that needs to know where to find the shards. So for manual discovery, I need to provide a mapping. And it's basically 3 lines of properties, but one of the lines can get very complex, especially if you have, let's say, 20 shards. In this case, I only have 4, and in my mapping, I'm specifying all of the server names where the shards are located. So if you're in AWS, you can understand that your server names are gonna change, so you must update this configuration, which can be a pain. So now I'm gonna go ahead and start my repository. And then I'm gonna navigate into the repository and validate that I'm able to search. So in order to do that, I go straight to the Node browser and execute a simple Lucene query, just to make sure that my queries work. And I can see that it returns my results. And what I want to show here too is the sharding page. Because I'm using manual sharding, it doesn't tell me anything about the shards because Alfresco doesn't know. So I'm gonna come back to this once we look at dynamic sharding. All right, so it's time to do dynamic sharding. So in this case, I'm gonna be using the exact same shards. I'm just gonna be changing my configuration on the repository side so that the repository can find the shards dynamically. It's just one line of configuration, basically enable it, restart my server. I'm gonna go back to the admin page and execute. Well, first I'm gonna check that sharding page. As you can see, now I have information about each shard. Now, what is really important about this page is that I have a number of shards that are available, and I also know the state of each shard. So this is very helpful, especially if you have multiple shards and once we get to high availability too. So the last thing to do once I have confirmed that my shards are available, I can just do a quick test that my search returns, executing the exact same losing query. And there it is, it returns. All right, let's continue. So if you want to know more about dynamic shard registration, there are a couple of Java files that you can take a look at. One of the things that you need to understand how it works is that the state of the shard is going to be reported by the metadata tracker. So if you want to see how that works, go and look into the metadata tracker.java. And the other thing that you need to know is that the repository stores the shard state and configuration using the attribute service. And the shard state is also put into a cache. You're going to see this cache definition in your caches.property file. And the name of the cache is shard state shared cache. You can also take a look at the shard registry info to find out more details on how shards are registered. So what exactly is a shard? So in Alfresco definitions, shards are considered to be part of the same index if they track the same store, they use the same template, which basically means to use the same schema, have the same number of shards, use the same partitioning method with the same configuration, and have the same setting to transform or ignore content. So let's dig into the actual service templates. So we have some templates available. ReRank, which is the recommended for sharding. We'll see in a minute why. The vanilla one, which is the one that we use for a single index. And there's another one called without suggest, which is based on the vanilla one, but it has no support for suggestions. So the two main templates that I want to talk about are the ReRank and the vanilla one. So the ReRank template is preferred for sharding because it causes less duplication of the index, which makes your index more compact. The vanilla one causes more duplication, and that's why you see sometimes your Solr indices being very, very large. The ReRank template also, the stop words are included in an index as common grams, while the vanilla template, stop words are removed from the words that are tokenized in the English language. And you can see the entire list of stop words for each of the templates in this location. I have highlighted, and this presentation is going to be published, so you will have the references there. The other thing that you need to know about the ReRank template is that it supports real ReRank with automatic phrasing, while the vanilla one, it performs auto phrasing without re-ranking. So there are differences to each template. Now let's take a look at what sharding methods we have available. So we're going to start with the ACL version 1, which was known as mod ACL ID method. This was available for Solr 4, and it's available for Solr 6. In Solr 4, this was the only method that you have available. So if you're in an older version of Alfresco and Solr, just keep in mind that that's the only way that you're going to be able to shard by ACL. Once you go to search services, you have DVID, date, metadata, ACL ID, which is the version 2, a better version of the ACL version 1. DVID range, my personal favorite, and the explicit method, which is included in the latest version of search services, which is 1.2. We also have an availability matrix. So if you're ever in doubt of what's available to you in your Alfresco version, you can always refer to this matrix, which is in our documentation. And for instance, if you are in Alfresco 5.1, you only can run with Solr 4, and you only have your ACL version 1 sharding. But if you go to Alfresco 5.2, which search services 1.2, then you have all of the methods available. Now, keep in mind that each method are unique. So certain methods are going to have features that the other ones do not have. The one I'd like to explain is the DBID range, which basically allows you to add shards as the index grow. This is very useful, especially if you go into Amazon and you want to set up an auto-scaling group. So if you want your index to grow as your repository grows, this is very flexible. If you're interested in a setup for that, tomorrow Tony De La Fuente is going to have a session, and he's going to go into more detail on how to do this in AWS. So I encourage you to attend that meeting. So how many shards do I need? From our billion document benchmark, we saw that a single shard can hold up to 50 million documents without a problem. And keep in mind, though, we did have a lot of replicas, so keep that in mind. Also, the only way to find out how many shards you need is to know your repository, because each repository is unique. Some people don't index content. Some people have a lot of content, and they have specific content types. So just like a regular index, it just depends on how your repository is structured, and just keep in mind that you gotta know your repository well, and just keep looking at patterns that you have in your repository. One of the things to know is that certain sharding methods do not allow you to add more shards without doing a full index. And in production, that's a big no-no for most companies. So a workaround to that is to overshard since the beginning. So you always define more shards than what you're gonna need. The other way to get around that is to use the DBID range sharding method, which, as I explained before, allows you to add shards on demand without doing a full index. So let's take a look at two different sharding methods, ACL and DBID range. All right, so we're gonna start with the ACL. So over here, we're gonna be using the same repository, and over here I only have 2 sites. But the key difference over here is that most of my content is in the DevCon demo site. So out of those 29,000 nodes that you guys saw, I wanna say 90% of my content is on this site, which means they all have the same ACL. So if I go, one of the key things about sharding is that your tracking nodes have to be part of the same cluster. And then over here, I have created my 4 shards using the ACL sharding method. All right, so I can see that my shards are available, and I can show the commands that I use to create my shards. So I have the sharding method as ACL, also specify the number of shards, the node instance, just like before, and the shard ID. And I did the same thing for all the 4 servers that I have available. All right, so that's very straightforward. Now I go into the summary page for each Solr server, and I can see that the first one has about 342 nodes. The second one has 461 nodes. The third shard, is only going to have 20 nodes. And my last one is the one that's going to have the most. That's where we have 28,000 nodes. And that's with the ACL, because as I mentioned, most of my documents are in one site, which have the same ACL. Now, if I create my shards using the DBID range, I can provide, as an admin, the range of my IDs. So I want the first shard to start from ID 0 to 7500. And my second server to have from 7501 to 15,000, 15,001 to 22,500, and 22,501 to 30,000. So that's how I'm gonna divide my shards. All right. So I go, make sure that they're part of the cluster. I can see that I already have my 4 shards. In this case, I define that I'm gonna have up to 100, but not all the shards need to be available. I can add them on demand. So now when I go into all of the summary pages for all of my shards, I can see how the first shard is gonna have 7,400 nodes. The second one is gonna have about 7,500 nodes. The third one, about 7,500 nodes. And the last one is gonna be about 7,000. So as you can see, it's a more evenly distributed index. Let's go back to the presentation. So how about file availability? So in order for me to have a high available sharding system, it's very straightforward. I just need to create multiple copies of my shards. So ideally, you want to do this in different servers. So if a server goes down, then the other server, which has a copy of our replica of your shard, they can take over. And one of the reasons also why you want to have multiple copies of each shard is to improve search performance. We did see that in our billion document benchmark when, as we added more shards, our response times for queries were faster because you have more shards to answer your queries. So let's do a quick demo on how to create highly available shards. I'm gonna go through this one fairly quickly because it's very trivial. So I'm gonna first create my initial 4 shards in my 4 servers. So I'm just gonna go on this one very quick just to show you what we have. So 1 shard per server. And then I go into my Alfresco page and I can see that I have 4 shards. So now in this scenario, if one of the server goes down, then I lose a shard. To avoid that scenario, I'm gonna reuse the servers for this demo. So I'm gonna be creating different shards on different servers. So server 1 is gonna host shard 0 and shard 1, as it can be seen here. And the same thing for the other servers. So each server is gonna hold 2 shards. So once I do that, I just gotta confirm that my Solr page also shows my 2 shards in each server. And then I can go into the repository and sharding page and check how many shards I have available. As you can see, I have 2 instances of each shard. So now in this case, if server 129 goes down, you may think that I lose shard 1 and 2, but if you look underneath, server 85 and 58 also have shard 1 and 2. All right. So how do you back up shards? It's very simple. We provide a web service which you call, and basically all it does, you call it and say which core you want to back up and the location where you want to back it up. One of the things you need to keep in mind is that if you're storing your backups in the same disk as your main index, if the disk fails, you're going to lose the main index and your backup. So make sure that you don't do that. I'm going to skip this demo for now since I'm running out of time. And the one thing I do want to mention is that if you're ever doing a large content ingestion, make sure that you tune these 2 parameters, which allows the shards to live longer. Otherwise, your shards are going to be taken offline while you're still ingesting, and users are going to be very angry that they cannot search. There are other tuning tips that I can give you, and one of them is always for Solr 4 specifically, change your max HTTP header, because if you have a lot of tags, your tag manager is not going to work. So make sure you increase that number. It's not set by default. In Solr 6, we increased that number by default, so that's no longer a problem. So are we out of time?
Yes, we are.
All right.
Since there's no other presentations in this room for the next 30 minutes, we'll take 5 minutes of questions. Does anybody have any questions for Jose? Go ahead.
I can tell you that from the customer.
Repeat the question, please.
Okay. So if I got this right, I think you asked if there was some kind of measurement on going from a single index to a sharded index, if we saw any improvement on performance, and at least for the customer I work for, which we were almost pushing 1 billion documents, we did see a huge improvement in terms of full index. We were able to do a full index in less than 4 days, when before it used to take about 14 days. The other thing that we did notice was our search times were faster, because we did add multiple replicas of each shard, and we went from performing a search that used to take, I want to say almost a minute, to less than 5 seconds. It was a big improvement. Any other questions?
So, did you notice this by sharding? You put a pretty big strain on your database, but not that environment.
In our case, we didn't notice a big difference on the database side, because our database was already tuned to handle more load than we were even expecting. So we had, if I remember correctly, 3 nodes of the database, Oracle database, and I think each server was capable of handling about 3,000 concurrent connections. So we didn't have a problem with that, but it's definitely something that you have to consider. And it's something I mentioned in my presentation, I just didn't have a chance to. But yeah, you definitely have to take a look at that. Any other questions? I'm also going to be available on the side if you guys have any questions, want to ask me anything specific. I have done this multiple times. We have moved from on-premise to AWS now, and also have some tips there. So feel free to come up to me. Thank you.
Thank you, Jose. Please vote for, leave your yay or nay and the chips outside the door on how successful you think this session was. Thank you, Jose. Everybody have a good day.